Hi everyone, today we're solving equations with variables on both sides of the equal sign. So our learning goals are, we are learning to solve linear equations with integer and rational number coefficients. We are learning to solve multi-step equations with variables on both sides. Take a look at the first example. I have 3 rectangles and 2 circles on one side. And I have 2 rectangles and 6 circles on the other side. If I wanted you to find the value of one green rectangle, one of these, what could you do to do that? Well, we can get rid of 2 rectangles on the right, which means I have to eliminate 2 rectangles on the left to keep it balanced. I can get rid of these 2 blue circles on the left, which means I have to get rid of 2 circles on the right. So I'm left with my one box is equal to 4 circles. How could I write this as an equation? Well, let me get rid of all my sketching. How could I write this as an equation? On the left side, I have 3 boxes plus 2 circles, and that's equal to 2 boxes and 6 circles. Now, we're going to solve this equation, but if you notice, it has variables on the left and the right side of the equal sign. But just do what you just did to eliminate things off of your scale. If you want to subtract 2x on both sides, you can do that. Could we have moved the blue circles first? Sure. It's up to you, as long as you know whatever you do to one side, you must do to the other. So 3x minus 2x, I'm left with my 1x plus 2 equals 6. And then we got rid of the blue circles by doing the inverse and subtracting them. Oops, 2. That's a 2. So I'm left with x is equal to 4. Let's try another picture. What balances with the cylinder? So now we want to figure out, what is a cylinder worth? Okay, so I have 1 cylinder on the left and 3 on the right. And then let's put 1s in all of these just for this example. So what would it do to solve for a cylinder? Well, you could eliminate 1 cylinder here, which means you have to eliminate 1 cylinder on the right side. What about my cubes? If I eliminate 1 cube here, I have to eliminate 1 cube here. Now I'm left with 2 cylinders is equal to 4 cubes. Do you know how much 1 cylinder is worth? 2 cubes. X is equal to 2. So let's write an equation based on the scale that you see. Well, I made these x's. So my equation would be 1x plus how many cubes? 5 is equal to 1 cube plus 3 cylinders, my x's. Now let's solve for x. Notice I have an x on the left and the right. You can move the cylinders or the cubes. It doesn't matter as long as you do the inverse operation. So let's get rid of our 1 cylinder on both sides. And I'm left with 5 is equal to 1 plus 2x. Now we can't move the variables anymore, so we have to move the constant by doing the inverse. And we're left with 2x is equal to 4. And this is a standard one-step equation. We had to divide both by the coefficient. So we're left with x is equal to 2, which is what we got in the picture. Let's try another example. Look, I have variables on both sides. You want to get all the variables to one side and all of the constants to another. And it doesn't matter if you put the variables on the left or the variables on the right. So I like to move the smaller coefficient by doing the inverse. So let's get rid of a minus 2x on both sides. Again, you could, if you wanted to, you could subtract 8x on both sides. It doesn't matter. The thing is, 2 minus 8, that's going to give you a negative number. And for whatever reason, sometimes when we go into the negative zone, that's when we make our mistakes. So a tip is to always move the smaller coefficient if you can. So I'm going to eliminate it over here, which means now I have 8x minus 2x is 6x plus 17 equals 35. So now I'm at a two-step equation, and I'm going to subtract 17 on both sides. So now I'm left with 6x is equal to 35 minus 17. And what is 35 minus 17? 18. So standard one step, let's divide by the coefficient, divide by the coefficient, x is equal to 3. And we can check it by plugging it in. Let's put 3 into our original equation where we have our x. So really we have 8 times 3 plus 17. Does that equal 2 times 3 plus 35? Well, 8 times 3 is 24 plus 17. Does that equal 2 times 3, which is 6, plus 35? Okay, well, 24 plus 17 is 41. Does that equal 35 plus 6, which is 41? Yes, then we did it correctly. The next example, 6 times the quantity of 4 minus x equals 2x. So we know we want to distribute these 6 to eliminate the parentheses and create an equivalent expression. 6 times 4 is 24. 6 times negative x is negative 6x equals 2x. Again, let's get the constants on one side and let's bring these variables together by doing the inverse. Now, some people might think to subtract 2x on both sides. You can totally do that. Remember, you can do whatever you want as long as you do the inverse. But then your equation is going to be 24 minus 6x and minus 2x is minus 8x. And what's left on the right side? 0. That's not wrong. You just have to do one more step. So you're actually making more work for yourself. So looking at your equation, you want to see what should be moved. In this case, we want to bring this variable over to his friend on the right by doing the inverse, and let's add 6x. Add 6x to both sides. We're left with 24 is equal to 2x plus 6x is 8x. Divide both sides by my coefficient, and x is equal to 3. Let's check it. 6 times the quantity 4 minus x equals 2 times 3. Does that equal? Well, 6 times, what's 4 minus? We're plugging in our 3. 4 minus 3 is 1. 6 times 1 is 6. And is that equal to 2 times 3, which is 6? Yay, we did it. So this one I've split my screen, and I'm going to show you why. So for this example, let's solve for x. Bring the constants together, bring the variables together. So I'm going to subtract 9/10 x on both sides. Remember, line up the decimal. And I'm left with 7 equals, bring down my negative 2, and what is 1 and 2/10 minus 9/10? That would be 3/10 x. So again, let's bring our constants together by adding 2 to both sides. So I'm left with 3/10 x is equal to 7 plus 2 is 9. Okay, the rules don't change. Just because there's a decimal, it doesn't matter. You're still going to follow the same procedure. Divide by 0.3 or 3/10. X is equal to, well, now we need to figure out what is 9 divided by 3/10. Remember to divide with a decimal. Move the decimal to the once in the divisor, which means you need to move it once in the dividend. So really you're doing 90 divided by 3, which would be 30. So I'm going to show you a trick, okay? I'm going to do the same exact equation, but I want to eliminate the decimals because I tend to make a mistake with decimals and I don't want to. Remember, you can do anything you want as long as you do it to both sides. What number could I multiply the whole equation by to eliminate my decimals? Well, if I multiply everything times 10, times 10, times 10, times 10, times 10, right? Watch what happens. 1 2/10 times 10. Right? I count my decimal place, goes in once, goes in once. 1 2/10 times 10 is 12. Ultimately, we're just moving the decimal one spot, one place value. So 1 2/10 times 10 is 12x. 10 times -2 is -20. 10 times 7 is 70. And 9/10 x times 10 is 9x. Okay? Look, 9/10 times 10 would be 90, but you have to move the decimal one spot in. Now, look at my equation. No decimals. Woo! So let's solve it. Let's move our variables first. Let's get rid of my lesser coefficient by subtracting 9x. So I'm left with 12x minus 9x is 3x is equal to, minus 20 equals 70. Let's add 20 on both sides. And I'm left with 3x equals 90. Look at that. Didn't we just do that over here? X is equal to 30. So the choice is yours. Solve it with the decimals or figure out what can I multiply the whole equation by to ultimately eliminate your decimals and make it a little bit easier. You'll still get the same answer. Woo, look at this doozy. Fractions, don't fear them, just distribute them. 3/2 times the quantity x plus 6 equals 16 plus 1/2 times the quantity x minus 24. So let's get rid of those parentheses and we'll have 3/2 x plus, what's 3/2 times 6? Well, 3 times 6 is 18. 18 divided by 2 is 9. Ooh, look, got rid of that decimal nice, or that fraction nice. Bring down my 16 plus, remember, you can't combine these two because addition does not come before multiplication. Order of operations. 1/2 times x is 1/2 x, and half of -24 is -12. Now let's solve this equation. Let's get our like terms together on the right side. 16 minus 12 is 4, plus 1/2 x equals 9 plus 3/2 x. Let's move the constants first in this one. Let's get rid of the smaller constant and subtract 4 on both sides. So I'm left with 3/2 x minus, or plus 5 is equal to 1/2 x. Now let's get the variables on both sides. So let's move this one by doing the inverse. Let's subtract 3/2 x, subtract 3/2 x. Let me extend my page. So I have 5 is equal to, what's 1/2 minus 3/2? Well, 1 minus 3 is -2/2. What's -2 divided by 2? -1x. Remember, we don't want a negative x, so let's divide both sides by the coefficient of -1. And we have x is equal to -5. See, not so scary after all. Let's take a look at a word problem. A batting machine uses an automatic baseball feeder. During baseball practice, the feeder is 1/6 full. An attendant fills it with 15 balls so that the feeder is now 2/3 full. How many baseballs does the feeder hold when full? All right, let's check this out. Let's write an equation. Here's my feeder, right? Do we know how many it holds when it's full? No, we don't. But during baseball practice, it is 1/6 full. 1/6 full is 1/6 of the full amount. Then an attendant fills it with 15 balls. So what operation is that? Plus the 15 balls. So that now the feeder is now 2/3 full. Let's solve it to find out how many balls does it hold when the whole thing is full, right? Because at first it was 1/6 full. 1, 2, 3, 4, 5, 6. Yeah, at first it was 1/6 full. Then we add 15 and it's 2/3. So we're going to have to figure out, right, how many balls does it hold when it's full. So let's bring our variables together by subtracting 1/6 x on both sides. Okay, fraction operations. So 15 is equal to, what's 2/3 minus 1/6? You need a common denominator of 6. So times 2 is 4. 6 minus 1/6 is 3/6. And we know that 3/6 simplifies to 1/2. So 15 is equal to 1/2 x. Now, how do I eliminate this fraction? Multiply by the reciprocal, flip it, because 1 cancels with 1, 2 cancels with 2, and we're left with x is equal to, what's 15 times 2? 30. That means that you can fit 30 baseballs in this feeder when it is full. Last question. Lainey and Jen buy the same number of books at the used book sale. Lainey buys paperback and Jen buys hardcover books. Lainey spends $1.50 less than Jen. Write and solve an equation to find the number of books each of them buy. Okay, let's read it again. Jen and Lainey buy the same number of books. So we're going to let x equal the number of books, because they're buying the same. If they both buy 5 books, they both buy 10 books. Lainey buys paperback books. So looking at our picture, this is Lainey. She buys paperback books and they're 45 cents. Jen buys the hardcover books. So this is Jen, $1.20 each. Lainey spends $1.50 less than Jen. So we have Jen, and we take away $1.50, and that's how much Lainey, if I could spell Lainey, spends. So let's write our equation that says that. How much is Jen spending? Well, we don't know how many books she buys, but we do know she spends $1.20 on each book. We don't know how many Lainey buys, but we do know she spends 45 cents per book. And Jen minus $1.50, because, Lainey spends $1.50 less than Jen. And that is our equation. So now let's continue on. Remember, Jen minus that $1.50, that's how much Lainey is spending. How many books did they buy? So let's eliminate let's bring our variables together, And so I'm going to subtract $1.20x on both sides. Okay. So I'm left with negative $1.50 is equal to, what's 45 cents minus $1.20? Negative 75 cents. So now, don't be scared of the decimal. We're going to divide by my coefficient. Even though it's negative, that's okay. 75 cents on both sides. So I'm left with positive x, which is my number of books. And what is negative $1.50 divided by negative 75 cents will be positive 2. That means that both girls bought 2 books. Right? Lainey bought 2 books at 45 cents, and Jen bought 2 books at $1.20. $1.20 2 times is $2.40. And 45 cents 2 times is 90 cents. Okay? It doesn't say that they spent the same amount of money, but it does say that Jen spent $1.50 less. Is that true? Yes, it is. Now let's go try some on our own.